All right. So since we now know how to use chemical nomenclature and turn words into chemical formulas, now we're going to take chemical reactions and instead of having them in word equations, we're going to have them in actual chemical formula and reactions. And we'll also discuss how we'll have to balance those reactions. But one of the things I want to talk about is when we look at a balanced chemical equation, what are we really looking at? So basically on your left side, these are referred to as your reactants, okay? Your reactants are your starting material, and your starting material react with one another. So typically they collide, bonds are broken, and then new bonds are going to be formed. And when those new bonds are formed, they produce new material. So typically we call those products. Those new materials, which is typically written on the right, is your product. Now what the arrow does, the arrow shows you the direction of the reaction. So with this particular reaction, we see on the left, we have sodium reacting with water, and it produces hydrogen and sodium hydroxide. Now there's a couple more things in this balanced equation that I want to mention to help you understand, not just the formulas and the arrow, but we also notice this delta symbol here. So a lot of times when you see that triangle, that delta symbol, what that means is heat is required for this reaction to go. Now, that's not exactly true for this particular reaction, but I just threw it in there just to show you that sometimes you will see a delta symbol. The other thing is you'll see the states of matter. So the states of matter are typically written as subscripts and they're in parentheses. So we see that the S, that's a solid. The L, that's going to be your liquid state. Your G obviously is your gas. And what a lot of people might not be familiar is the AQ is aqueous or aqueous. And, that refers to something being dissolved in water. And you can think of aqueous, and agua or aqua, right, which means of water. And then the last thing we have to make sure, again, because of the law of conservation of mass, is that the amount of mass on both the reactants and products side is the same, right? Because we can't create or destroy matter. We can only transform it. So we have to make sure that we have just as many atoms on both sides, all right? And to do the balancing of that, we use what are referred to as coefficients, and I underline these coefficients. Now, when you don't see a coefficient in front of a formula, like in the case of this hydrogen, we know that there's actually a 1 there. A 1's not necessary because you wouldn't actually write out the formula if there wasn't at least 1. So don't think that is a 0 because some people do that and that's not correct. There's at least 1. Again, when we're balancing equations, we are going to use these coefficients and we're not going to change formulas and change the subscripts. So if, I wanted the 2H2O, I'm not going to write H4O2. That doesn't exist. And I'm going to use the coefficient to help me balance out the hydrogens and the oxygens that way. So I hope that helps. If you guys have any comments, go ahead and leave them in the comment section. And thank you for your time, and I appreciate you showing up.